In my last report, I went a little deep into the technical details as I started adding lighting to The Dungeon Under My House, my second freshly squeezed entertainment project. If you've been following along, you know that The Dungeon Under My House will be a non-violent, first-person dungeon crawler, and as a freshly squeezed entertainment project, it will be a polished, playable prototype that provides a complete entertainment experience. It will be freely available for desktop computers as well as mobile devices with no ads, no in-app purchases, and no personal data tracking. Hello and welcome. My name is Gianfranco Berardi, my pronouns are he, him, his, and I encourage curiosity and support creativity through my solo indie game development studio, GB Games LLC. I'm really happy you're here to join me on this indie game development journey. In this week's freshly squeezed progress report, you can see the link to the companion blog post in the description, I continued the work of adding lighting to my dungeon, which partly involved identifying how my approach to representing my dungeon's data so far was slowing things down needlessly. A lot, in fact. The dungeon rendering was very slow. And ultimately I was able to speed things up substantially by making a simple change to match what most people do in game development in the first place. Okay, so last time I had added lighting to the walls and doors, which was relatively easy to do. I just looked up the light level in the relevant cell and applied a tint when rendering the column of the texture. Ceilings and floors, however, render each pixel by grabbing the pixel data of the texture and plopping it into a larger 960 by 288 texture, which gets rendered to the viewport. For both the ceiling and the floor together, that's 960 by 576 pixels to iterate through. And without lighting, it's quite fast, as you can see. Luckily, it turned out that what I thought was going to be the hard part, applying tint to the pixel data, was fairly straightforward, but the code slowed to a stuttering crawl. Why? Well, it turns out there were a few things going on, and to give you fair warning, this is going to get a bit technical again. I represent my dungeon using a standard map of point to dungeon grid cell. I could have an arbitrary shape for my dungeon, and the map would only have data stored for the actual dungeon cells. It seemed efficient, and it worked for my purposes so far. When I created lighting data, I populated a similar map of point to dungeon light. When I need to know the light level of a particular cell in the dungeon, I can look it up by its position in that map. And it works. This is functional code. I can see that the dungeon is actually lit up appropriately. But, as you saw before, and as you can see now, it wasn't very efficient. I can see that traversing the dungeon isn't very smoothly animated. And my code was making it even worse. Let me explain this ridiculousness to you. See, I took a shortcut, and I wrote some code that asked for the map's element by position. If the cell exists at that position, it's fine. I get the cell data, and I move on. But if the cell didn't exist at that position, then the map would add a default initialized cell to the map at that position. And what this means in practice is that whenever the ceiling and floor rendering code projected out and needed to get the lighting for a particular cell in the dungeon, my 33-cell test dungeon suddenly had 10,000 plus entries of lighting data to search through. For all those pixels, each of them doing this, that's a lot of computation. A map is guaranteed to find an element in a collection in logarithmic time. That's pretty fast compared to iterating over each element to find the element you want, but it is still slow in this context. And even when I prevented the code from adding entries to the map, searching through those original 33 entries was still a lot of extra computation for processing each of those 500,000 pixels. But what if I didn't use a map? What if I used a one-dimensional collection, such as a vector? Accessing an element by its index is guaranteed to be done in constant time. That's really fast. So I created a vector of dungeon light. And now, whenever I want to access a cell's lighting data, I just had to do some simple and quick math to get the index, such as the cell's x position added to the cell's y position multiplied by the dimensions of the dungeon. If the index is within bounds of the vector, I can continue processing the pixel by its cell's lighting data, and if it isn't within the bounds of the vector, then I stop processing that pixel. It's simple, and it's efficient. Even though I still have other optimizations to do, you can see that as I travel around the dungeon, the animated transitions are much smoother. Using a one-dimensional array or vector is typical in game development. So why didn't I do this in the first place? Well, it was never a concern before. A dungeon level on a 2D grid could be represented in many ways, and in the past I've used a vector of vectors to represent 2D data like that. It's functional, and in the past it was always fast enough. I believe in writing efficient code because I want to respect the player's hardware and battery usage. In fact, weeks ago I had written some code to ensure that the dungeon view only re-renders when it needs to, so if the player is stationary, it does not need to do any extra unnecessary rendering calculations. But I also believe in being practical. Unless the code is a bottleneck, prematurely optimizing isn't going to result in a significant benefit. What I didn't realize was that my data structures were resulting in such an increase in computation until it actually significantly impacted the performance of my rendering code. My use of a map was directly responsible for creating a bottleneck, one that got eliminated as a concern once I switched to the vector. So now I know, and my code is much faster for it, which means my raycasting code is able to handle lighting in real time, which means the player will have a much more enjoyable experience. And actually, with these new lighting changes, I think I'm going to need to record updated footage for the intro for these devlog videos. Thanks for watching, and stay curious. Now, if you want to learn when I release the Dungeon Under My House, or about future freshly squeezed entertainment games I am creating, then sign up for the GB Games Curiosities newsletter and download full-color player's guides to my existing and future games for free. Again, check the links in the description.